All right, guys. So let's go ahead and start practicing definite integrals. We still haven't done the fundamental theorem of calculus yet, which will be sometime. Maybe we'll start it Friday. Maybe we'll do it next week. We'll see. So let's start. Example. The regions A, B, C, and D in the figure to the right are bounded by the graph of the function f and the x-axis. The area of region A is 9, so I'm going to put 9. The area of region B is 8, so I'm going to put 8. The area of region C is 4, so I'm going to put 4. And the area of region D is 9, so I'm going to put 9. What is the value from negative 6 to 0? So I'm going from here to 0. So the integral from negative 6 to 0 of this function, f of x dx, is equal to, so this 9 is below the x-axis, so that's going to be negative 9. And then that 8 is above the x-axis, so I'll put plus 8. Remember that integral just means area under the curve, so negative 9 plus 8 is going to be, and you're done. Cool or not cool? Yeah, it's pretty basic. I think most of y'all will understand this pretty quickly. Example, the next one, it says the function f is shown below. What is the value from negative 9 to 9? So notice this time they do not give you any numbers, so that means we have to calculate this by hand. And you're just going to do basic shapes, geometric shapes that we are aware of. So I can see that I have a rectangle there, and then a triangle, and another triangle. All right, so let's find this rectangle here. Let's see, this 1, 2, 3. So this is 3 by 2, so that means this area is 6. Do you see how I got the 6 there? All right, so now let's see. 1, 2, 3, 3 times 1, 1, 2, 3. 3 times 3 is 9. 9 divided by 2 is, excuse me, I'm going to put it as 4.5. And then let's see, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. 5 times 5 is 25. 25 divided by 2 is 25, 12.5. So those are the areas. And then here's one big triangle. That one in red. All you need is the height, the perpendicular height. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 3 is 30. Divided by 2, it is 15. Add them all up. Let's see. 6 plus 4.5 plus 12.5 plus 15. It's some number. I do not know what that number is because that is 38. And there it is. Everything's above the x-axis, and that's the area. Come on, Revia, focus. Oh, I thought you were 10. You don't have to, as long as you're calculating area, you know what I mean? And remember that area is in square units. All right, next one, same thing, but you got to keep a note that you have some area below the x-axis and above the x-axis. Oh, and this one, they don't want the whole thing. They just want a part of it. Okay, so they want the area between 1 and 9. If you want, you could do a triangle, a rectangle, another triangle, but I see a certain shape. What shape do you see? Yeah, I see a trapezoid, so I'm just going to do that trapezoid formula. So let's see, area of a trapezoid. The height is 2, base 1 is 2, base 2 is, the difference between 9 and 1 is 8. So let me make sure, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, but this is way faster. Look, 2's cancel out, that's just 10. Cool or not cool, guys?
Wait, what is the original formula?
Area of a trapezoid is height base 1 plus base 2 divided by 2. Oh, this answer is not 10. The area is 10. What is this answer for this integral? Negative 10. Oh, I almost got one wrong. I was about to go to the next question and say that we're done. Cool or not cool? So that's what you would type in, negative 10 on this one if it were a delta math assignment, which it is. Hint, hint. All right, next one. Now we have a semicircle in there. The function f is shown to the right. It is comprised of a semicircle and a piecewise linear function segments. What is the area between 0 and 9? You're just using geometry, guys. They're not going to give you any shape that you do not know. So here's 0. So everything that's in red is what I want. And 9. So that's a triangle and that's a semicircle. Let's find out well, that's a quarter circle, really. Let's find out the area of that quarter circle. How do I find the area of a circle? Pi squared, and that's a quarter of a circle, so I'm going to divide by 4. So the radius is 2. So let's see. 2 squared is 4. 4 pi divided by 4, you just get pi. So this part right here is pi. Don't worry, it's negative pi, but we'll add it in a little bit. And now here's a triangle. The difference between 9 and 2 is 7. 7 times 3 is 21. 21 divided by 2 is it 10.5? All right, so the answer, negative pi plus 10.5. Cool or not cool? Okay. Yeah. Well, I think the way they probably want it like common denominator. So let's see. 10.5 is the same thing as 21 over 2. So they probably want it like either this way or negative 2 pi plus 21 over 2. They both mean the same thing. All right. Next question. Notice this time we have no numbers. There are no shapes that are regular, so we're just going to have to look at it with vision. And you're not actually calculating anything. You're just circling an answer here. So it says, given the function f graph below, determine which of the following listed integrals is less than than the other three. So that means which one's the smallest. So let me read. Which one is the smallest number? Remember, the more negative it is, the smaller it is. So negative 100 is smaller than 1,000 or whatever. Cool? Or than 5. Negative 100 is smaller than 5. All right, letter A, negative 4 to 2. From negative 4 to 2, that's definitely negative. So I'm just going to put less than 0. It's not a big negative number, but it's negative. From negative 7 to 0, let's see, negative 7 to 0. That looks like it's definitely negative, but it looks like it's kind of be close to like the number 0, no? Okay, so, and then I'm going to put close to 0 because it almost zeroes out. Between 0 and 8, well, yeah, this is a big negative. Big negative. Which is what I want because that's smaller. Does that make sense? And then between negative 7 and negative 4, that's a worse answer. Do not choose letter D. Why do I not choose letter D? Yeah, it's a positive. That's the biggest one. So if you want to put biggest, that letter D one is the one. So the answer in this one is going to be C. Cool or not cool? Cool. Let's go to the next one. Okay, this time they do give you values, and we're going to have to use properties. Let's see, the region A, B, C, and D in the figure below are bounded by the graph of the function f and the x-axis. The area of each enclosed region are labeled in the figure with their respective numerical values. What is the value of? All right, here's how you do it. Remember our properties that we had 2 days, yesterday, was it yesterday or 2 days ago? All the days are being mixed up. I think it was yesterday. And look, this right here, I can just break this up into this, negative 1 to 8 of f of x dx minus integral from negative 1 to 8 of 4 dx. Does that make sense, guys? This I can calculate real quick. This one here I can calculate real fast. Let's see, negative 1's here and 8's here. So that is negative 3 plus 9 minus 8, whatever that is. And then this right here in blue that I'm circling, that's just a rectangle, guys. So I'm going to sketch the graph here. That's just a rectangle. Look, here's negative 1, here is 8, and the height is always 4. So, look at this. Find the area of that rectangle. So the difference between 8 and negative 1 is 9, and what's 9 times 4? So, I'm going to be adding whatever this is right here. I'm going to add, well, actually it says minus. I'm going to subtract, that is this number, 36. Does that make sense to you guys? Well, because you weren't here, so you weren't part of the properties. Does that make sense? Cortez, does that make sense or no? You can be honest with me. No? Okay.
Wait, I thought you just subtract 4 from that product, like that sum.
No, because that means area under the curve of y equals 4. And this is just going to give me a flat rectangle. So, do you understand how I broke it up with the properties? Right, and then this is just -1 to 1 is -3, so -3. And then 1 to 4 is 9, so 9. And
Yeah,
then
I get that part.
Okay, perfect.
36.
Now, this part right here, that's just like, remember, this is your f of x. So I'm saying that my f of x is a constant 4. Like, it's always 4. And remember that we learned that this means literally area under the curve. Does that make sense? So 9 times 4 is 36, because that's what this difference is. And it's always 4. So it's just one rectangle. How do we feel, guys? All right. And when we add them up and subtract them, what do you guys get? Oh, man. What'd you get? Okay, I believe you. We still got some more? Last one. This one's easy. All right. We're gonna go slow on this one. If I go too fast, let me know, and I'll try to slow down. Let f be a continuous function such that from the area under the curve from 7 to 9 of this function is -7. Area under the curve from -6 to 9 of this function is -2. What is the value from 7 to -6 of 1/3 f of x? All right, to make it simple for you, bring that 1/3 out. So what they want is this 1/3 integral 7 to -6 of f of x dx. Cool or not cool?
Yes.
Cool. So here's what I'm going to do. I'm focusing on this in blue. I'm focusing on that in blue. So let me draw a visual for you guys. This is not to scale because obviously the areas are negative, so I should be drawing stuff below the x-axis. And then let me draw this vertical line right here. So I'm going to say, where do I start? -6 and then 7. So this is just a visual, guys. You don't have to write this down. Just listen right now so you can take it in, really understand this. All right, so just, drop the pencil, just listen. So if I want the area from -6 to -7, if I wanted this area, you would agree. Does everyone agree that I would go, let's see, what do they give me? I would say area under the curve. Let me write the 9 here. I have this -6 to 9 of this function. That's all in blue. They give me that. It's this one right here. Of course, I know it says -2. Relax, guys. I'm just doing a visual. And if I subtract, notice that this. If I subtract this right, -6 to 7. If I subtract this in red, that's the area under the curve from -6 to 7, correct? That's what I want. I want the area under the curve from -6 to 7 because then I can use my properties to just flip. Does that make sense or no, guys? Yeah, once I know this, I can just use my properties, negate them, or put this up there, put this one down there, and put a negative in front. Cool or not cool? Cool. All right, so now you can write. Yeah, so let's do it. So I'm going to find the total area between -6 and 9, which I already know, and I'm going to subtract the area between 7 and 9 of this function. The area under the curve from -6 to 9 is -2. And I'm going to subtract the area from 7 to 9, which is -7. So I get 5. Does everyone get 5? Okay, so I guess I'm going to write the property here real quick. So area under the curve from -6 to 7 of this function is simply 5. So then I'm going to write this 1/3 integral 7 to -6 of this function is simply 1/3 times -5. And what's 1/3 times -5? Yeah, -5/3, yeah. Don't be scared, guys. How do we feel? Yeah, so that's all you have today. That's all you're going to be doing on Delta Math. You're just going to be doing more and more problems like this so you can practice. So right now the key is to practice because practice makes progress. So let's practice, guys. Hopefully everyone will be done with it today. Don't forget that I want the Delta Math due today, but don't forget we have a UH quiz And that one, I want you to attempt tonight. If you're fast enough, you can do all 3 of them before you leave the class. So, and I believe you guys are fast enough.
There's 3 quizzes?
So, there's 3 total assignments. 2 on Delta Math and then the UH quiz on 10.
What unit is it?
22. So UH quiz 22, attempt tonight, and it's due on Friday. Is that enough time, guys? Is there a video on YouTube already? Yes, there's already a video on YouTube. What's up? What's up, Olivia? You got it?
Can you print out the other ones for me?
Yes.